Good morning. This is Robert, the math teacher, and we have been looking at the different concepts that you would normally learn in an Algebra 1 course. And so the last time we were studying how to solve one-step equations. And so as an example, let's look at this one sample problem, 3x equals 18. Now, the number 3 there is a coefficient in front of the variable. And so what that's saying is actually 3 times x. That's 3 x's. So x plus x plus x. So 3 x's equals 18. And so what we need to do is use the opposite operation in order to isolate the x, in order to get the x by itself. So what is the inverse operation, the opposite operation of multiplication? It's division. So we would take this 3x equals 18 and we would divide by 3. But we have to do it to both sides. And that's because otherwise we are changing the equation. So if we divide both sides by 3, then 3 divided by 3 is 1. So now the 3's cancel out. And so now we have 18 divided by 3. And so what is 18 divided by 3? Well, that's 6. So x equals 6. Now we can go back and we can replace the x with 6. So if we go back, we have 3, and it was times x, right? So 3 times x, which was 6, equals 18. And now we can test our solution. Does that work? Is 3 times 6 equal to 18? And in fact, it does. It does equal 18. So that means that our solution is correct. So now we have another example. Negative 4x equals negative 28. Again, negative 4 is the coefficient of the variable, so we need to get rid of that because we want the x by itself. We need to isolate it. So if I divide the left-hand side, though, by negative 4, I need to do the same thing to the right side. So negative 4x divided by negative 4 equals negative 28 divided by negative 4. And again, the reason I did that is because if I only divide one side by negative 4, I would be changing the equation. So negative 4 divided by negative 4 is 1. So again, that cancels out. And negative 28 divided by negative 4 is positive 7. So x equals 7. And now we're going to test this again. Negative 4 times 7 equals negative 28. And this is true. So that means that our solution is correct. Now, here's another one. Now, this might be a little more tricky. So we have 3/5 x equals 9. So now our coefficient in front of our variable is a fraction. We're multiplying by a fraction. So how could I make that equal to just x? What can I do to get rid of 3/5? Well, if I multiply it by 5, then I'm getting rid of the 5 in the denominator, right? So I could put 5 here. And then if I divide by 3, then I am getting rid of that 3 in the numerator. So 5/3. So now I can multiply it by 5/3. So now I have 3/5, and I am going to multiply 3/5 by 5/3, and that means that both of these will cancel out. Both the 5 and the 3's. So now the 5's and the 3's cancel out. But since I did that to the left-hand side, I multiplied the left-hand side by 5/3, I need to do the same thing to the right. So times 5/3. Now 9 is the same thing as 9 divided by 1. So now, because the multiplication is a commutative operation, that means that I can switch. 1 times 3 equals 3 times 1. Then really, I could rewrite that as 9 over 3 times 5 over 1. 9 over 3 times 5 over 1. And now, when I do that, it's obvious how I can simplify this, right? 3 goes into 9 3 times, and it goes into 3 one time. So that simplifies to 3 over 1. And 3 over 1 times 5 is 15. So 15 is my solution. And again, I can go back and I can test this and see, does this work? So I had the original equation was 3/5 x equals 9. So 3/5 and x, I'm substituting with 15 because I'm saying that 15 solves the equation, and that's what x is equal to. And I'm saying that this equals 9 because that's what the original problem said, to see if I solved this correctly. Now, I don't have to rewrite the 5. I don't have to move it over, but I just did that just to show you it more clearly. But 15 divided by 5 is 3 over 1. So 3, so that simplifies to 3 times 3 equals 9, which is, of course, true. So that means that we have solved that problem. Okay, so now let's look at our next problem. So we have x minus 5 equals -2. So what is the opposite operation, the inverse operation of subtraction? It's addition. So to get x by itself, if I add 5 to both sides, then I will have isolated x. So now I'd go ahead and do that. So x minus 5 equals -2. I add 5, but I have to do it to both sides. So the -5 and the +5, they cancel out. And so now I have -2 plus 5 is 3. So x equals 3. And 3 minus 5 is indeed -2. Okay, so now we're going to look at the next one, x plus 4 equals 9. And this is all just to review before we start with two-step equations. Now, x plus 4 equals 9. This has addition in it. The opposite of adding is, of course, subtracting, so that's the inverse operation. So I subtract 4, and when I do it to the left-hand side, I have to do it to the right. So those cancel, and I get x equals 5. 5 plus 4 is clearly 9, so we know that this is correct as well. And then finally, we have 3x equals 24. 3 is a coefficient, so again, that means multiplication. Because that's x plus x plus x, so I have 3 x's, so it's 3 times x equals 24. So I have to divide, because that is the opposite operation of multiplication. So I divide both sides by 3, and I get x equals 8. So x equals 8. Okay, so that helped us to kind of review these operations, these one-step equations, and to think about inverse operations. Now let's look at two-step equations and see how we solve them. So you may remember when you are evaluating an expression, the PEMDAS, the order of operations. Please excuse my dear Aunt Sally. Well, what does PEMDAS tell us? It tells us the order in which I'm supposed to perform my operations, in order to solve the equation. So, or in order to evaluate the expression, excuse me, in order to evaluate the expression. So that means parentheses first, exponent second, the M stands for multiplication, then division, then the A stands for addition, and the S stands for subtraction. And so the first thing that I do when I'm evaluating an expression is parentheses. The second thing would be exponent, and then third would be either multiplication or division, and then the fourth thing would be addition or subtraction. So when I'm solving an equation, I'm doing the opposite of this order. So first I do addition or subtraction, and then I do multiplication or division. Okay, so it's the opposite of the order of operations. So I'm just going to write opposite of the order of operations. Okay, so to solve an equation. Okay, so 2x plus 5 equals 13. Well, okay, so the opposite. Okay, so first we have to identify our operation that we need to get rid of first. And remember again, we just said that addition and subtraction must be dealt with first. So we see addition there. The opposite operation, the inverse operation of addition is, of course, subtraction. So 2x plus 5 equals 13. I am going to subtract 5 from both sides. When I do that, then I have 2x equals 8. Now, I'm going to go ahead and I see 2x equals 8. Well, I know how to solve that. That is just like what these previous equations that I've been solving looked like. They were one step, right? This is 2 times x equals 8. So the opposite operation of multiplication is again division. So I divide both sides by 8, so I don't change my equation. So 2x equals 8 becomes x equals 4 because 8 divided by 2 is 4. And if I put that back in, and I can kind of do that mentally, 2 times 4 is 8. 8 plus 5 is 13. So yes, this does work, but we'll write it out anyway. 2 times 4 plus 5 does equal 13. So we know this is correct. Now, let's do another example. So we have 3x minus 4 equals 11. So again, we do addition or subtraction first. So we have subtraction here. So minus 4. So the opposite of subtraction is addition. So we have to add 4 to both sides. So plus 4 to both sides. And I get 3x equals 15. The negative 4 and the positive 4 cancel out. And then 3x equals 15. That means 3 times x equals 15. So I divide both sides by 3. And I get x equals 5. And 3 times 5 is 15, minus 4 is 11, so that does work. And now we have this last example that we're going to look at. 5 minus x equals 2. So now we've got, this looks different, doesn't it? So, but really, this is the same as negative x plus 5 equals 2. So let's rewrite it. Negative x plus 5 equals 2. Now we subtract 5 from both sides. So now I have negative x equals, and 2 minus 5 is negative 3. So negative x equals negative 3. Divide both sides by negative 1, and I get x equals 3. And 5 minus 3 is indeed 2. So these are our examples of solving two-step equations. And so I want you to remember, okay, so when we have two-step equations, we need to remember PEMDAS and realize that we're doing the opposite of PEMDAS. Okay, so we're doing the opposite of PEMDAS. We're going to do our inverse operation for addition or subtraction first. Then we're going to do our opposite operation of multiplication and division. Okay. So I hope this was helpful, and I look forward to seeing you all next time. Thank you and have a great day.